Hi everyone, this is Neel Raithatha, also known as the Wax Whisperer. Thank you for joining me in my latest video. We have here a patient who reported a blocked left ear, and this is their right ear that we're examining. So this is partially blocked, and you can see the consistency of this earwax. It's really soft and wet and loose, and they have got a collapsed entrance to their ear canal, which can make the procedure a bit more difficult because we're having to use the endoscope to widen and dilate the entrance of the ear canal in order to not only view the inside of the ear and the wet earwax, but also enough to insert the instrument into the ear to remove this wax. At its resting state, when it's closed, it's not possible to insert the instruments, and that's because the diameter of the instruments, both the suction probe and the endoscope, is greater than the diameter of the entrance of the ear canal. So what I'm doing, I'm actually widening the ear canal with my instrument hand, that's my right hand. And so I do that by pulling the ear back and up. Our ears are slightly inclined and we've got several bends and kinks in the ear canal. So in an adult ear, if you pull the pinna, which is the satellite dish on either side of our ears, the cartilage on the outside, if you gently pull that back, so posteriorly and then upwards superiorly, it straightens and widens the ear canal. And then to keep that ear canal open, I'm using the endoscope, which I'm holding in my left hand. So the right hand side of the tip of the endoscope, I'm pushing up against the right side of the ear canal. So I'm using the endoscope almost like a doorstop, a crowbar, and I'm ensuring the endoscope's at the bottom right of the ear canal when I'm doing this. And that then allows me to use the instrument to also then slowly push the cartilage to the right to further straighten it before inserting it into a straight line into the ear. And that's how you straighten an ear canal. And the reason why I've just described that in a bit more depth is because I had a few specialists who just wanted a bit of reminding about the technique, who recently trained myself and were recently qualified. So I hope that's useful. Now, as you can see, this earwax is very difficult to remove because it's really wet and it's impacted on the eardrum. Now, this patient has got the gene for wet earwax. There's a single gene mutation which codes for the type of earwax we've got. So there's two types of earwax, broadly speaking, two main categories, dry and wet. And the gene responsible for determining which type of wax you have is called the ABCC11 gene. Now, if you have a functioning ABCC11 gene, sorry, it codes for a protein that transports lipid-liking molecules into the ceruminous glands. So the ceruminous glands are glands found exclusively in our ear canal, under our armpits and our inner groin region, and they secrete an oily sweat. So if you have a functioning ABCC11 gene, and that basically means you have a dominant guanine allele. The ceruminous gland has access to these lipid-liking molecules, and these lipid-liking molecules pair up. And when they pair up, they are either naturally odorous, or when they're secreted and push up the pores in the outer third of the ear canal, because these ceruminous glands are found in the cartilage portion of the ear canal, the outer third. When this oily sweat is transported up the glands and up the pores to the surface of the ear canal, there's bacteria there that feed off these compounds, these double lipid-liking molecules, and after the bacteria feed off it, they then release an odorous smell. And these two lipid molecules, there's many types of lipid-liking molecules, but they do pair up in different combinations. And they are naturally less viscous. So not only if you have a functioning ABCC11 gene that you are coding for additional oily sweats, but these oily sweats are less viscous, so they're more watery in viscosity, and they either naturally are odorous or they become odorous once bacteria feed off them. So that's why if you have wet earwax, then you're very likely to have odorous sweat under your armpits. If you have a non-functioning ABCC11 gene, so you have two homozygous adenine alleles, recessive adenine alleles, this ABCC11 gene is non-functional, so the protein that transports these lipid-liking molecules into the cerebrous glands across the membranes are not active, so the cerebrous glands don't have access to these lipid-liking molecules, so they can't form into pairs. They're not excreted up the cerebrous gland ports to the surface of the ear canal, so you get a more viscous, oily sweat in the absence of that particular gene working, and the more viscous, oily sweat is less odorous. So you get so if you've got the dry earwax, then you're very likely to have less body odor under your armpits. Most of the Western society, I think 80 to 90% have the wet earwax gene. So European, the African, if you're from African descent. If you're more from the Far East or the North Americas, then you're more likely to have dry earwax. So it's a small percentage globally, but the predominant gene in the Far East is the dry earwax. So it serves an advantage there. Now, the exact reason for that is unknown, but it's led to believe that having less of this body odor in your armpits is more appealing to potential partners in the Far East. So if you do have this body odor on your armpits, and also wet earwax, then you're less likely to find your mate in the Far East. They're more adverse to that. That's the theory. I don't know if it's true. Ironically, if you have the dry earwax gene, then you also women produce less breast milk. So again, I don't know the advantage of that, but that's what that gene codes for. It codes for wet earwax and more breast milk. So I hope you found that interesting. We've removed the left ear a while back, just mopping up the right side. There's a bit of keratin there. You can see the eardrum, it's not your textbook eardrum, but it's fully functioning. There's no pathology there. Again, this ear canal is quite elastic, very elastic cartilage this patient's got, which makes it easier to stretch open, actually. That could also be the reason why it's folded over itself there. So if you've got a piece of plastic in the house, I mean, my laundry basket is made of plastic and it's round at the top, that plastic, it can kind of fall over itself. It's got that elasticity, so it can bend and fold over itself, and possibly because this patient's got elastic cartilage, it's folded upon itself. Well, I hope you enjoyed that video, guys. Take care, keep well, and speak soon. Bye.